the total energy of electron. Kinetic energy, we'll first calculate the kinetic energy of electron. Now kinetic energy T equals to half mvn square, where vn is the velocity of electron on nth orbit. Now vn equals to e square by 2 epsilon naught nh. We'll put the value of vn on the expression of kinetic energy T. Now we'll get T equals to half m e to the power 4 by 4 epsilon naught square n square h square, which is equals to half m e to the power 4 by 4 epsilon naught square n square h cut square into 4 pi square equals to m e to the power 4 by 32 epsilon naught square h cut square pi square n square. So this is the value of kinetic energy. Now from our previous class we know that Rn equals to n square h cut square by m e square into 4 pi epsilon naught. Now we will calculate the potential energy. Now potential energy V equals to integration infinity to Rn e square by 4 pi epsilon naught Rn square drn, which is equals to, if we integrate it, we'll get it as minus a square by 4 pi epsilon naught into Rn. Integrating this, we'll get the value of minus e square by 4 pi epsilon naught into Rn, which is equals to minus e square by 4 pi epsilon naught. Now we will put the value of Rn here. Then it will be putting the value of Rn, which is n square h cut square by m into the e square into 4 pi epsilon naught. We'll get minus m e to the power 4 by now we have the value of potential energy V, which is equals to minus m e to the power 4 by 16 pi square epsilon naught square h cut square into n square. Okay, now as we have calculated the kinetic energy of the electron, kinetic energy T, which is equals to m e to the power 4 by 32 pi square epsilon naught square into h cut square n square. And potential energy of the electron V, potential energy V, which is equals to minus m e to the power 4 by 16 pi square epsilon naught square h cut square n square. Okay, now the total energy of the electron, the total energy En will represent it as En, which is T plus V, that means kinetic energy plus potential energy. Now En equals to m e to the power 4 by 32 epsilon square pi square epsilon naught square h cut square by n square minus a potential energy, that is minus m e to the power 4 by 16 pi square epsilon naught square h cut square into n square. Okay, now after the calculation we'll get the value of total energy as m e to the power 4 by okay, so this is our total energy En. Now En equals to minus 13.6 by n square EV. If we put the values of those constant, then we'll get this value, that is En equals to minus 13.6 by n square, where n can take values like 1, 2, 3 and so on. For n equals to 1, E1 equals to minus 13.6. We called minus 13.6 EV, we called it as ground state energy. Ground state energy of the ground state is minus 13.6 EV in case of hydrogen atom actually, and for where n can take, for n equals to 2, 3, 4 and other values, we'll get the values of E2, E3, E4, which are the excited states. Okay, now we can express our energy levels with horizontal lines and we can draw them in this fashion. So for n equals to 1, energy is E1, and n equals to 2, energy is E2, and up to n equals to infinity, at n equals to infinity, E infinity is 0, and above n equals to infinity the energy levels gets a continuous form. So above n equals to infinity we get a continuum, and this diagram is called as energy level diagram. Now, the amount of energy required to remove the electron from its ground state is called as ionization energy, which is mod value of E1. It's called the ionization energy. Now, when electron make transition from energy state Ei to EF, applying Bohr's frequency rule, we get nu equals to Ei minus EF by H, which is equals to m e to the power 4 by 2 by 8 epsilon square into h cube into 1 by n f square minus 1 by ni square. Here we have put the value of energy Ei, and remember there was a minus sign in the expression of energy, that's why we get it in this way. Now wave number nu bar equals to 1 by lambda, which is equals to nu by c. Now putting the value of nu here, we'll get nu bar equals to 1 by lambda, which is equals to m e to the power 4 by 8 epsilon naught square h cube into c into 1 by nf square minus 1 by ni square. Now we'll express it as R infinity into 1 by nf square minus 1 by ni square, where R infinity equals to m e to the power 4 by 8 epsilon naught square h cube into c. We called this R infinity as Rydberg constant. Rydberg constant for infinite nuclear mass. Now nu bar equals to R infinity into 1 by nf square minus 1 by ni square. Now we will consider the different values of nf and ni. If nf equals to 1, then 1 by lambda equals to R infinity into 1 by 1 square minus 1 by ni square. So whenever nf equals to 1, ni can take values 2, 3, 4 and so on. So whenever nf equals to 1, ni will start from 2, 3 and it can go on from 2, 3, 4 in this way. Okay, and whenever nf equals to 1, we get Lyman series. Now 1 by lambda equals to R infinity into 1 by 2 square minus 1 by ni square. So here we have taken that nf equals to 2. So here nf equals to 2. So ni can take values from 3. So ni equals to 3, 4, 5, 6 and so on. So whenever nf equals to 2, that means electron is making transition from higher state to n equals to 2 state. We get Balmer series. Now, depending on the values of nf, we get also 3 different kind of series which are called for nf equals to 3. We get partition series where nf equals to 3 and ni takes values from 4, 5, 6 and so on. And for nf equals to 4, we get bracket series. Here nf equals to 4 and ni equals to 5, 6, 7 and higher values. Similarly, for nf equals to 5, whenever nf equals to 5 and ni takes values 6, 7, 8 and higher values, we get Fund series. So in this way, we also get these 3 different kind of series. So these are the different series which we get. Now remember one thing, that our Lyman series lies on the ultraviolet region of EM spectrum and Balmer series lies on the visible region, whereas Paschen, Bracket and Fund, these 3 series lies in the infrared region of EM spectrum. Okay, now here we can see that depending on the different values of nf, we get different kind of series on, like for n equals to 1, nf equals to 1, we get Lyman series. For nf equals to 2, we get Balmer series. So whenever electron make transition from higher state to ni equals to 1 state, we get Lyman series. And similarly, whenever electron make transition from higher state to n equals to 2 state, we get Balmer series. And similarly, whenever electron make transition from n equals to 4, 5, 6 or any higher state to n equals to 3 state, we get Paschen series. So depending on the values of nf, we get different kind of series. Now for nf equals to 5, whenever electron makes transition from any higher state to nf equals to 5 state, we get Fund series. So here nf equals to 5 and ni can take values from 6. So ni can take values 6, 7, 8 and any higher values. So whenever nf equals to 5, we get Fund series. So today we have discussed about the total energy of electron and hydrogen spectrum, and on our next class we'll discuss about the magnetic moment of electron.